Warahmatullahi wabarakatuh. Okay. Uh, we are from the group 4. So this is our presentation for our project. So we are going to start with the introduction to stability analysis and PID controller. Okay, stability analysis is a crucial aspect of control system engineering. It's used to determine the stability of a system, which is defined as the ability to maintain its equilibrium state in the presence of the disturbance. If a system is unstable, it means that small disturbance can cause large and unpredictable change in the system behavior. On the other hand, a stable system is one where small disturbance result in small, predictable changes. Okay, for the PID controller, PID controller is one of the most widely used controllers in control system engineering. A PID controller continuously calculates an error values as the difference between a desired set point and a measured process variable, and it applies the correction based on proportional, integral, and derivative terms. Okay, the proportional terms provides a correction to the proportional to the error. The integral term provides a correction that is proportional to the accumulated error over time, and the derivative term provides a correction that is proportional to the rate of change of the error.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Suhaizi bin Muhammad Skifli, and my metric number is AA212547. For the first objective for circuit 1 is firstly insert the formula to the Simulink to get the graph, and then for the calculation we use the closed loop formula to get the latest transfer function, and to find the x value we need to insert the equation using the quadratic formula and convert it to imaginary number. For the second objective, we input the circuit into the Simulink, and the component is step, subtract, transfer function, and the scope. To get the info, steady state error, overshoot, rising time, and peak time, we need to insert the step info into the coding and until we get the answer. And that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad bin Muhammad, and today I will present circuit number 2. So for the circuit number 2, the equation given is 20 over s squared plus 2s plus 9. So we need to use mathematical calculation to find the roots and to find the poles and zeros. So after we get the poles and zeros, we need to find the roots. For denominator, we need to use the quadratic equation to find the roots. So after we find the root, we get the value of x1 is -1 plus minus 5.2915i. For the x2 is -1 plus 5.2915i. So we need to sketch the graph, and this is the pole zero slot plot cache circuit closed loop system. For the question number 2, this is the step response graph. We get the stable closed loop system. The overshoot for this graph is 55.2090. The rise time is 0.2224. The settling time is 3.7156, and the steady state error is 0.31. For the PID controller meet control system design equipment, we use the MATLAB to find and we get this result. We get the stable closed loop system. The overshoot is 0. The rise time is 0.0112. the settling time is 0.0210 and the steady state error is 0. So that is all for the circuit number 2.
Assalamualaikum and salam sejahtera. My name is Muhammad Atisafi bin Syafizal. Number matrix AA210840. So today I will explain about the circuit tree. So for the transfer function that we got is 250 over x square plus 4s plus 50. So for this, as we can see, this question is open closed loop. So that we going to use a closed loop equation, which is ds over is equal to gs over 1 plus ss plus times gs. So after we use the equation, then we will get the answer for the x is equal to negative 4 plus minus say 4 square minus 4 is times with 1 and times with 300 over 2 times 1. And for the S1 and S2, we will get is negative 2 plus 70.2J, and for the S2, we will get negative 2 plus minus negative 2 minus 17.2I. So and then we can see the sketch that we have to sketch by our own self. And then for the second one is PZM, which is pole zero map. As you can see, we got two pole, and then for the characteristic of B, we got a stable closed loop, and then for the overshoot we got 63.3900, and then for the rest time we got 0.0659, and then for setting time we got 1.8667, and then for steady state error 1 minus 0.831 is equal to 0.169. Then you can see the graph. So for the PID controller, we got stable, and then for the overshoot we got 0, and then for the rest time is 8.8213, and then for the settling time we got 0.0016, and then for steady state error we got 1 minus 1 is equal to 0. So this is our graph that we got from the MATLAB. Thank you.